We're going to look at it's called Explain the Difference lesson, and the purpose of this lesson is to help you figure out which formula you should use for a given scenario. So what we'll do is I'll show you two example pages of what I'm trying to get you to work on here, and they all start with what's the difference between, and they give you two of the types of formulas that we've been using. And then there's an example of each type of formula. And so first I want you to write down what's the difference between those two concepts, and then you'll have to identify which problem goes. Is it this problem that goes with compound interest, or is it this problem that goes with compound interest? And the other one is probably going to be an annuities problem. So on the second page here I have another pair. I'm comparing this time continuous compounding and installment loans. And then I have two different problems for you to look at to see which one should use which formula. And then you have a worksheet, and let me show you real quick how to get to that worksheet. It's in my math lab, and if you go to course materials and click to open that up, and then go to, I believe it's in other resources. Yeah, the other resources, and down here you can see the Explain the Difference worksheet. So if you click on that, then up comes your worksheet, and you should print, and you can see over here on this little gray bar there's a little print icon, and you can just click that to print your worksheet. It is very similar to what we're doing, but you'll have different concepts that you're comparing on each page. So this page is annuities and installment loans. The next page is installment loans and compound interest. And let's see, I have 3 pages. And then the final page is installment loans, compound interest. Third page, simple and compound interest. So some examples for those. This will help you immensely in terms of helping you sort out which formula you use for what type of scenario. So it's in a little bit smaller chunk. After you complete this project, then the next thing that you're going to do is, I'll show you on your homework list. You can see I'm way behind. I'm trying to find where to go to. Oh, I haven't assigned them yet. Okay. I'll show you on this view. This is the teacher view. Yours is very similar, of course. But down here, once you've completed this Explain the Difference worksheet, then I want you to go onto my math lab and complete the Choose the Right Formula. And that's on the schedule for the next class after today's class. So Choose the Right Formula. It is a worksheet, it is a my math lab page of problems, and so you'll work through those and do just a little bit more work figuring out which formula goes with which type of problem. So you're going to need to be looking at your formula journal entries. If you're not sure about this, they will help you immensely in terms of figuring out what is involved in a particular formula, the keywords that you need to identify which formula to use, and just the basic concepts about the different formulas that we've been using. So I'm hoping these 2 days will help you get to the point where you're ready to take the exam, and you'll know which formula to apply in all the different situations I give you. So back to our worksheet. This is Explain the Difference. It's page 19 in your activity guide. And the first thing I want to do is answer this question: what's the difference between compound interest and annuities? And we want to see if we can write out a sentence explaining the main difference between the two, just like we've been doing for our formula journals. So I'm going to walk you through just 2 more examples of this, and then you'll be on your own. Starting with compound interest. What do we know about compound interest? Well, for compound interest, I know I start with a large chunk of money and I deposit it into the bank. And then I know that I gain interest every month or year, could even be quarters. That's every N times per year. So whatever our N is, that's how many times my interest is being calculated. The interest is being added back into the account. So the interest gets put back into the account and can gain interest on its own. That's kind of cool. And what else do we know about this? At the end of the investment period, you get a bigger chunk. Of money. Okay, so that's pretty much all I can think of about compound interest. So I think I've hit all the highlights of how compound interest is calculated, how you start with a big chunk of money, end up with an even bigger chunk. Let's look at annuities now and compare point by point. Does annuities have that same feature, or is there something different going on? So to start with, get my pointer. You start with a large chunk of money that you deposit into the bank for compound interest. Now with annuities, I know it doesn't work that way, so I'm going to write out for annuities, you make, and I'll put in parentheses because small is a relative word, but small-ish deposits every month, or it could be every year, or whatever is going to be N times a year. So every month we put some money into the account. Not a huge amount, a smaller amount. And what's happening next on compound interest is that we gain interest every month or year, or exactly N times per year. So with annuities, that's going to be the same thing, so we can just put a check mark. No different, does that too. And for compound interest, interest is added back into the account and gains more interest. For annuities, it's the exact same thing. When you put the money back, when you earn the interest, it goes back into the account every month or every year, however often your interest is being calculated. So no difference there. Annuities works the same. At the end of the investment period, you get a bigger chunk of money. And for annuities, that's also true. At the end of the investment and I'm just going to say on this one, a big chunk of money. Because up to this point, we've been talking small beans every month, small amount, small amount, small amount, and at the end, all that compounded interest and all those extra deposits add up, and you get a big chunk at the end with an annuity. It's the same thing. You're going to still get a very large amount of money out from compound interest, and depending on how much you're depositing, etc. So these are pretty close to equal. There's just a slight difference between the two. Okay, so our main difference here is you start with a big chunk of money for your compound interest and you don't make any further payments. And for the annuities, you're making a small payment every N times per year. Okay, see if we can put that into a sentence here. So with compound interest, You deposit. So I'll say we'll leave it sit because we don't take the money out, we don't add any money to it, we just leave the money there to earn our interest for us. Okay, so that's for compound interest. There it is. And then we'll use our $1 million math word here, while with annuities you make in deposits a year, and that's really the big difference right there. So we're either putting in one big chunk at the start and leaving it sit, or we're making end deposits a year. The first one is compound interest, the second one is annuities. So let's look at what's going on with our two problems and see if we can figure them out.